Now, summer storms are a very common occurrence in Johannesburg and other high-fell regions, and indeed, this weather phenomenon has actually proved to be quite dangerous in most recent times because 2 girls in Soweto were struck by lightning last week, and 9 cricketers at the King Edward School, boys that were busy covering the pitches on the school grounds, were struck by lightning. And I think most of us don't really understand how this phenomenon of lightning works. So our presenter, Linda Mbuso, went to speak to Dr. Ian Jandrell to find out exactly how lightning works and why it can sometimes be so dangerous.
We take a closer look at the science behind thunderstorms because in January, 3 teenagers were killed in KwaZulu-Natal. And last week, Johannesburg school pupils were struck by lightning.
Lightning strikes cause serious injury and even death to many South Africans throughout the year. Today we are out here at Wits University to speak to Professor Ian Jandrell to find out about the causes of lightning strikes and the effects it could have on you.
Lightning is a very complex phenomenon and has been studied in South Africa for nearly 100 years.
There have been recent stories of lightning strikes and injury in South Africa. What are the physics behind a lightning strike?
It's a very good question. I think one of the first important things is to try and develop a methodology which allows us to understand the physical phenomena, because if you look at a lightning strike, it's a very dramatic event. It's ionized plasma. And what we try to do in the laboratory is to create an example of that which allows us to better understand that phenomena. And I can show you that effect right now.
This enormous electrical discharge is caused by an imbalance between positive and negative charges. A flash of lightning could power a light bulb for a month.
So what you saw there was a very small example of the plasma that's formed during a lightning strike. But what's very important is that we start to understand how lightning actually forms. The first thing we require is a thundercloud. Now that may sound quite silly, but without a thundercloud, you simply do not get lightning. And the interesting thing about a thundercloud, which is a cumulonimbus cloud, is you get what we refer to as charge separation. And what that means is you get positive charge clustered together and negative charge clustered together. Typically, you get positive charge at the top of the cloud and the negative charge closer to the base of the cloud. Now the interesting thing about that is that most lightning, therefore, that strikes the Earth starts off in the negative charge center. Most lightning, not all of it, but most lightning. Now, when it starts off in the negative charge center, we call this negative downward lightning. That's about 90% of all the lightning strike in the Earth. That kind of lightning strikes the tallest object. Not necessarily the top, but the tallest object. The problem with the other kind of lightning, positive downward lightning, remember that positive charge center? That lightning, which is about 5% of all lightning, will not strike the tallest object. Positive downward lightning will literally strike whatever's underneath it. So for instance, you could be on a street outside the Carlton Centre. Negative downward lightning would strike the top of the Carlton Centre or near the top. Positive downward lightning could literally travel down the side of the building in the air and strike the ground on the roadway next to the building.
Thus, it's dangerous to be standing in a flat open space during a storm, as you're then the highest point.
What are the physical effects of being struck by lightning?
Right, so the first important point, and obviously when there's ever been a lightning strike, an injury, one must express your sympathy, and it's a very unfortunate event. Fortunately, it's fairly rare. The probability of being directly struck by lightning is actually very, very slight. Of course, it does happen, but it doesn't happen very often. There are a number of instances where people have been very severely hurt and have survived, and there have been other instances where all that's happened is the heart is fibrillated, and because nobody could revive that person, they've actually either gone into a coma or they've passed on, which is very, very unfortunate. And so as much as it's important to understand what to do to protect yourself from a lightning storm, get indoors, stay out of high places, and make sure that you understand when a storm's approaching, you must take these actions. It's equally important to know what to do if somebody's injured in a lightning storm.
There are also quite a few myths around lightning strikes in South Africa and the effects it has on people. Could we just demystify a few of those?
Every good engineer will answer a question like that by saying it depends. So it depends on the circumstances of the physical environment in which you find yourself, but the general good advice, based on the assumption that I do not know how anybody else's house has been earthed, what the foundation looks like, and so forth, the good advice is the following. In a thunderstorm, stay out of the swimming pool, stay out of the shower, stay out of the bath, and don't talk on a landline telephone. That's good advice. because it could be dangerous and therefore could put you at risk.
Separate fact from fiction. For example, the practices of covering mirrors during storms or placing car tires on the roof have no scientific basis. Know your lightning facts and stay safe in the storm.